Every spring you plant the same beds. Every summer the same insects find them. You deal with it. They come back. You deal with it again. They adapt faster than you do. At some point, every gardener asks the same honest question: why does this keep repeating? And almost every answer you get points back at you. React faster. Monitor more. Spray earlier. But none of that advice addresses the actual problem, which is not your response time. It is the fact that your garden has no defense structure built into it at all. You built a food system. You did not build a protection system. And every bed without one is, from a pest perspective, a meal with no guard. There is a category of plant that changes this permanently. Self-seeding perennials that return every season without replanting, developing deeper root systems year after year, producing more chemical output every season, and quietly making your garden harder to navigate for every pest that has been finding you. Some of them work below the surface, disrupting pests in your soil before they ever reach your plant roots. Some of them chemically restructure the air above your bed so that flying insects cannot locate the plants they are hunting. 9 of them are on this list. 2 I want you to hold in mind as we go through it. Somewhere in the middle of this list is a plant most gardeners grow as a purely visual addition. What it actually manufactures inside its leaf tissue has been studied at the cellular level for the way it interacts with insect nerve signal pathways, not by herbalists, by pharmacologists. I will tell you exactly what the compound is and how to position the plant to get maximum output from it. And the last plant. This one will sting a little. There is a reasonable chance you have already removed it from your garden, called it a weed, composted it without a second thought. It may be the most chemically productive pest-deterrent perennial that self-seeds in a temperate garden. By the end of this video, you will not make that mistake again. If this is the kind of content you want consistently, subscribe now and hit the bell. Practical plant science every week. Let us get into it. Plant number 1, valerian. The mistake most gardeners make with valerian is treating it as a herb garden plant. They grow it for its medicinal reputation, tuck it into a dedicated herb section, harvest the roots occasionally, and never once consider what those roots are doing to the soil they are buried in. That separation is costing them considerably. Valerian's most meaningful work as a companion plant happens below your soil surface, in the root zone, invisibly, across the entire growing season. And the pest it works against most directly is one most gardeners never see at all. Soil-dwelling cutworm larvae and wireworms that sever seedlings at the root collar overnight and leave no trace of how or why a healthy plant collapsed by morning. What makes valerian's history interesting is where the knowledge comes from. Rudolf Steiner's biodynamic agricultural framework, developed in the 1920s and still used across certified biodynamic farms in over 60 countries, placed valerian root preparations at the center of soil biology management, not as folklore, but as a deliberate intervention based on decades of observation that valerian root chemistry changed how pest populations behaved in treated soil zones. That specificity of use across generations of serious farming practice is not the profile of an accidental discovery. The chemistry behind it is now documented. Valerian roots produce compounds called valipotriates alongside isovaleric acid and valerianic acid. The valipotriates have demonstrated direct cellular toxicity against soft-bodied invertebrate larvae in laboratory research, disrupting their development at concentrations achievable within the root zone of an established valerian plant. Isovaleric acid, which gives valerian its characteristic pungent root scent, has shown interference with chemoreceptor navigation in soil-dwelling insects at the ground level. These pests locate host plant roots by chemical signal. Valerian disrupts that signal at the source. Most gardeners growing valerian are doing it for the wrong reason entirely, which means the right reason: a living underground chemical barrier actively working against the pests that destroy plants without warning is already available to them and going completely unused. How to use it. Plant valerian 15 to 18 inches from your most vulnerable seedling areas, particularly beds where overnight seedling collapse has occurred without explanation. Full sun produces the strongest root development and highest compound output. Leave roots undisturbed between seasons. Second and third year root systems are significantly more chemical active than first year plants. Allow it to self-seed freely and remove spent flower heads if spread is a concern in smaller gardens. Avoid transplanting established plants because root disturbance interrupts the underground chemistry that makes this plant useful. Perennial in zones 4 through 9. Plant number 2, catmint. Most gardeners who grow catmint grow it for the pollinators. They watch bumblebees work through the flower spikes. Think of it as a nice ecological contribution and push it to the back of a bed where it has room to sprawl. That placement is precisely what is making it useless as a companion plant. Catmint's protective mechanism is entirely aerial. It works through volatile chemistry dispersed into the surrounding air. Move it to the back edge of the garden, and you have physically separated it from the problem it could be solving. Catmint appears in ancient Persian agricultural records as a boundary crop, grown explicitly as a living perimeter, and not for food or medicine. Medieval European kitchen garden layouts positioned it along vegetable rows consistently. Generations of gardeners observed that plants growing near it fared better against insect colonization. They were right. They simply did not have the chemistry to explain what they were seeing. The active compound is nepetalactone. Research from Iowa State University demonstrated that nepetalactone triggers a genuine alarm response in aphid colonies. When aphids detect it, they respond as though a predator has entered the colony. They drop from the plant, they scatter. They do not regroup and attempt to reestablish. Separate research confirmed that the same compound disrupts the host-finding behavior of whiteflies and thrips by masking the chemical signature of nearby plants. A single mature, blooming catmint plant produces enough volatile output in calm air to create a meaningful disruption zone extending several feet in all directions. This is not a background plant. It belongs on the front line of your most vulnerable beds, not behind them. How to use it. Plant 18 inches apart along the windward side of your target beds. 3 to 5 established plants protect 8 to 10 feet of bed length effectively. Full sun is essential because shade reduces volatile output significantly. After the first bloom flush, cut plants back by half. This triggers a strong second flush and extends peak volatile production deep into the growing season. Avoid heavy fertilization. High nitrogen creates lush growth with lower compound concentrations. Catmint is perennial in zones 3 through 8 and self-seeds reliably after establishment. You plant it once and manage its spread, not its survival. Plant number 3, tansy. Everything covered so far has been about what happens above ground and just below it. Plant 3 changes the frame entirely. Most gardeners who grow tansy grow it because it is visually striking. Yellow button flowers, deeply cut aromatic foliage, easy to establish from seed. They put it somewhere with good light, harvest a handful of leaves occasionally, and think of it as a pleasant addition. They are benefiting from perhaps a quarter of what it actually does. Tansy releases a dense array of compounds continuously from its root system throughout the growing season. These root exudates, primarily through zone and related monoterpene derivatives, create an underground chemical environment that is hostile to wireworms and the larvae of several beetle species that colonize root zones with no visible warning above ground. The damage these organisms cause looks like nutrient deficiency. It looks like overwatering. It almost never looks like pests until the plant is already lost. Here is the detail most companion planting resources never mention. The strength of tansy's underground chemical signal is directly proportional to planting density. One plant creates a limited zone of root exudate activity. 3 plants spaced closely, root systems overlapping and compounding, produce a chemical saturation in the surrounding soil that reaches concentrations capable of measurable pest suppression. Research into tansy's allelopathic properties confirmed disrupted larval development in target pest populations within treated soil zones. This is a plant where more is not just better. More is the entire strategy, how to use it. Plant in clusters of 3 to 5, never as single specimens, 10 to 12 inches apart. Allow root systems to develop and overlap, because that overlap is where the effect lives. Full sun and lean, well-drained soil produce higher compound concentrations than enriched beds. Tansy spreads aggressively by both rhizome and seed. Use a root barrier or remove seed heads before dispersal if spread is a concern. Perennial in zones 3 through 9 with no winter intervention needed. Plant number 4, hyssop. At the beginning of this video, I told you plant 4 was the most misused companion plant in any garden. Here is exactly why and exactly how to correct it. Most gardeners who grow hyssop keep it in a dedicated herb section. They harvest it for cooking, appreciate the purple flower spikes for aesthetics, and treat its companion planting value as an afterthought. That separation is what eliminates almost all of its protective function. Hyssop is a dual-action plant. Its volatile blend, primarily compounds called pinocamphone and isopinocamphone, disrupts the host detection behavior of cabbage white butterflies and aphids, reducing their ability to locate and land on nearby crops. Simultaneously, its open flower structure is one of the most efficient landing platforms in any garden for parasitic wasps and hoverflies, the insects that hunt aphid colonies directly. The plant repels the pest with one mechanism and summons the pest's predator with another. Both functions are range-dependent. At 10 feet from your brassica bed, hyssop is doing next to nothing for it. At 3 feet, interplanted directly within the growing area, it is running both mechanisms simultaneously across the exact plants that need them. The mistake is not which plant gardeners choose. It is where they put it, how to use it. Interplant hyssop directly within brassica beds, not beside them, within them. 1 plant per 4 to 5 square feet of growing area, full sun and well-drained soil. Do not cut hyssop back during the growing season. The flowers are where the beneficial insect attraction concentrates. Harvest after bloom ends. Allow some plants to self-seed freely each year to maintain an established colony without replanting. Perennial in zones 3 through 10. Avoid overwatering, because wet roots in poorly draining soil are the primary cause of hyssop failure. Plant number 5, fennel. Almost every experienced gardener has been told to keep fennel away from everything. Separate bed, isolated corner, possibly not even in the garden at all. What most of them do not realize is that this advice is built on a half-truth, and the half they are acting on is stripping them of one of the most powerful dual-action perennials available. Fennel's allelopathic tendency is real, but it is selective and it is root proximity dependent. For certain crops at the right distance, well-established fennel is simultaneously disrupting pests and recruiting the insects that destroy them. The volatile compound transanethol, present at high concentrations in mature fennel foliage, interferes with the host location behavior of aphids and whiteflies. Separate from that, fennel's flat open flower clusters are among the most productive foraging sites in any garden for parasitic wasps and hoverflies, the insects that locate and destroy aphid colonies. The plant pushes pests away with its chemistry and pulls their predators in with its flowers. At the same time, in the same space. Here is where most gardeners have it wrong. They remove fennel from vegetable areas entirely. What they should be doing is positioning second or third year fennel, not fresh transplants, but established plants with mature root systems and full bloom at 18 to 24 inches from tomatoes, peppers, and brassicas. That distance neutralizes the allelopathic root competition. The volatile and flower attraction effects remain fully active. How to use it. Establish fennel as a fixed perennial position at the edge of your vegetable area, 18 to 24 inches from the nearest crops. Do not uproot between seasons. Second and third year plants produce significantly more flower coverage and volatile output than first year transplants, and that is where the real value is. Full sun, self-seeds aggressively, thin to the strongest plants each spring. Keep away from dill to prevent cross-pollination. Avoid planting near kohlrabi and beans, where the allelopathic effect is most pronounced. Perennial in zones 4 through 9. Before the last 3 plants on this list, I want to mention something briefly. Everything we have talked about today, the precise placement, the density requirements, the timing of bloom and root maturity across the growing season, all of it depends on one thing most gardeners never fully address: planning ahead, knowing what goes where, when, and what comes after it. Most gardens sit underproductive for months of the year, not because the gardener is doing anything wrong, but because nobody ever handed them a complete year-round system. Beds sit idle between seasons. Planting windows get missed. The garden produces in bursts and then stops. I wish someone had given me this before I wasted entire seasons reacting instead of planning. That is what the year-round harvest blueprint solves. It is a practical, season-by-season guide to keeping your garden producing from the first thaw through the last frost, with succession strategies, seasonal crop guides, and a full planning pack included. Worksheets, harvest trackers, and quick reference seasonal guides so the timing is never a guess. The link is in the description. The bonus planning pack is included at the current price, and that may change. If year-round productivity is where you want to take your garden, do not skip past that link. Now, the next 3 plants are where this list becomes genuinely unexpected. One of them has compounds that have been studied in contexts that have nothing to do with gardening at all. Let us keep going. Plant number 6, wormwood. Most gardeners who encounter wormwood think of it as a structural ornamental. The silver-gray foliage is distinctive. It earns its place in a decorative border purely on appearance. And that is precisely where it usually stays, appreciated for how it looks, and completely underestimated for what it is doing. What wormwood manufactures continuously in its foliage is a group of sesquiterpene lactones, including absinthin, ardabsin, and thujone, with a research history that extends far outside any gardening literature. Thujone has been studied in pharmacological research for its activity on neurological receptors. It is the compound that made absinthe controversial for over a century. Ardabsin and related compounds have been investigated in veterinary medicine as antiparasitic agents, specifically because of their ability to disrupt invertebrate nervous system function at low concentrations. That is the same mechanism that makes wormwood effective in your garden against aphids, cabbage moths, and carrot fly. And it is operating continuously from the foliage, not just when leaves are crushed or disturbed. The plant emits this chemical output passively, all season, in every direction. Most of the gardeners growing wormwood as a decorative border plant are receiving this protection without knowing it. You now know exactly what is producing it and why, how to use it. Position wormwood 2 to 3 feet from the nearest vegetable crops, close enough for foliar volatile dispersal, and far enough to avoid allelopathic root competition at the soil level. Full sun essential. Lean, dry soil produces higher concentrations of active compounds than rich or heavily watered beds. Cut back by 1/3 in early summer to promote fresh growth and extend volatile output across the season. Self-seeds reliably in zones 4 through 9. Among the most drought-tolerant plants on this entire list once established. Plant number 7. Stinging nettle. The instinct to remove nettle is almost universal. It stings on contact, spreads aggressively, and looks nothing like something worth keeping. That reaction is completely understandable. It is also one of the most consistently costly decisions a gardener can make. Stinging nettle has been used as a practical pest management tool across traditional East Asian and Central European farming for centuries. Fermented nettle liquid, leaves steeped in water for 10 to 14 days, represents one of the earliest documented homemade pest deterrents in agricultural history, applied to foliage and soil long before modern horticulture had a framework to explain what it was doing. The chemistry is specific. Nettle leaf tissue contains formic acid, acetylcholine, and histamine. Fermented nettle extract demonstrated contact toxicity against aphids and spider mites in direct application research. But the living plant also does something subtler. Established nettle clumps host early-season aphid colonies that arrive before your vegetables are established, and those colonies draw hoverflies and predatory ground beetles into your growing area weeks before the main pest season begins. The plant baits your garden's natural defenders in before the attack starts. Most gardeners are pulling their own recruitment system out of the ground and calling it weeding. How to use it. Allow 1 or 2 plants to establish at the outer edge of your growing area, adjacent to beds but not within them. Cut back before seeds set to manage spread. For nettle pest spray, street fresh leaves in water for 10 to 14 days. Dilute 1 part liquid to 10 parts water, strain thoroughly, and apply directly to affected foliage in the evening. Gloves at every stage of handling. Perennial in zones 3 through 10. Plant number 8. Rue. Rue's story as a companion plant is not a Western story. Its documented history as a practical pest management tool comes primarily from North African, Ethiopian, and wider Mediterranean farming traditions, regions where it was grown in deliberate rows alongside vegetable plots as a living insect barrier for generations. In those traditions, it was not a decorative plant. It was infrastructure. The active compounds, alkaloids, and furanocoumarins, including rutin and chalopensin, have been studied for their interference with chemoreceptor function in pest insects, including Japanese beetles, onion flies, and aphids. Furanocoumarin research has documented reduced host-finding accuracy in multiple target species at concentrations. Rue produces naturally in a healthy, established planting. Rue does not kill pests outright. It makes your garden harder to locate and harder to navigate. There is something worth sitting with in that distinction. A garden that pests read poorly is a fundamentally different environment than one they find effortlessly every season. How to use it. Position rue 18 to 24 inches from brassicas, leeks, and any bed with persistent beetle or fly pressure. Full sun, lean and well-drained soil. Richer conditions reduce the concentration of active compounds, which is the opposite of what you want. Trim lightly in early spring to encourage fresh growth. Self-seeds modestly and manageably. Wear gloves when handling in direct sunlight, as the furanocoumarins can cause skin sensitivity on contact. Perennial in zones 4 through 9. Plant number 9. Borage. Every other plant on this list earns its place through one primary mechanism. Borage earns its place through 3 simultaneously, which is why it belongs at the end and why it may be the most practical single addition you can make to any vegetable garden. After the first season, borage self-seeds so reliably that replanting becomes a concept without practical meaning. It simply returns. Its deep taproots break compacted soil, draw minerals from below the root zones of surrounding plants, and deposit them back at the surface as the leaves break down through winter. Its open flower structure is among the most productive foraging sites in any garden for hoverflies and parasitic wasps. and companion planting research focused specifically on brassica and tomato beds has documented that borage foliage deters cabbage worm and tomato hornworm from establishing on adjacent plants. You plant it once, your garden plants it every season after that. How to use it. Direct sow once, allow it to go fully to seed at season end, and let it return on its own terms every year from that point. Thin to 1 plant per square foot in spring. Full sun, average unfertilized soil, borage does not need or benefit from rich beds. Position it specifically near tomatoes and brassicas, where the pest deterrence research is most documented. Flowers and young leaves are edible. Perennial by self-seeding habit in zones 3 through 11. Something shifts when you understand what a garden actually is at the chemistry level. Every plant on this list built its defenses under pressure, not through human breeding programs, not through any intervention, through millions of years of being attacked and adapting to survive it. The compounds inside these plants are not incidental. They are the evidence of an arms race that has been running longer than agriculture itself. We did not engineer any of this. We are simply learning, slowly, to stop working against it. A garden built with this understanding is not just a place where food grows. It is a system where the plants are already solving problems before you arrive in the morning, where the chemistry in the soil is already disrupting pest cycles you will never see, where the air above your beds is already harder to navigate for every insect looking for an easy meal. That garden does not happen by accident. It happens by planting deliberately, once, and then letting things that have had millions of years of practice do what they were built to do. Start with 2 plants from this list, not all 9, 2. Put them in the right position, give them a full season, and pay attention. What changes will not require any explanation from me. If this video gave you something you will actually use in the ground this season, subscribe and hit the bell. Real plant science and practical garden strategy every week. Drop a comment below with 2 things. Which garden type you are working with, raised beds, containers, or open ground, and which pest has given you the most consistent trouble. My next recommendation depends entirely on your answer. I read every single one. And if this content saved a plant you were close to losing, super thanks is always appreciated. It goes straight back into making more of this.